This is the tutorial for graphing and writing linear equations, handout number 1. So taking a look at the first problem that you'll end up seeing, it asks us to graph lines using the slope and y-intercept. So that's what we're going to do here. So we look at this number right here, this value, this positive 1, represents our y-intercept. It's where we end up starting the line. So we're going to have to go 3 spaces up on the graph, and actually, I'm sorry, 1 space up on the graph, and put a dot right there at 1 space up. And then we look at the slope. The slope is the number that changes the x value, changes the input, changes the domain each time. And then we always add 1 to that value to come up with the output. So our slope is the fraction form of that number. And the fraction of 3 is 3 to 1. Well, that tells me to go up 3 and then right 1 space. And so if I do that, from this y-intercept, I'm going up 1, 2, 3, and then over 1 space to the right. That's where I end up getting. I could also go the other way. I could also go down 3, and then left 1, because 2 negatives make a positive. So if, again, from that point, down 3 spaces, 1, 2, 3, left 1 space puts me on that line. And then from that point, I can go ahead and draw the line between those points. And that is our answer. So the next one asks us to graph using xy intercepts. So when I'm doing that, I'm setting one of the variables equal to 0. And here I'm going to find the x-intercept. So I'm setting y equal to 0. I go ahead and solve by multiplying by the reciprocal. I end up with x equals 4. So 4 spaces to the right, I put a dot. And then for the y-intercept, I'm setting x equal to 0, and I divide by 2. And when I do that, I end up with y equals 1. So I go up 1 space, put a dot, and then draw the line between those points. Well, the next set of directions asks us to graph the system of equations. That means we have to graph on the same line, so our same coordinate plane. So when we see those braces around 2 equations, that means they want us to graph on the same coordinate plane. We're also going to state the solution. The solution is where they intersect, where lines intersect. So where they end up crossing. And so let's take a look at this problem. -3, so we're going down 1, 2, 3 spaces, put a dot right there, and then use the slope. So we're going up 2 spaces over 1 space. So up 2 spaces, over 1 space. And so that's the line we end up getting. I'm going to use, I'll use blue to draw that line. So it gives us a few points. And so let's take a look at the next line. I'll use a different color to show that it's a different line here. And we'll start at positive 2 for the y-intercept there, and you use the slope. Down 1, 2 to the right. So down 1 space, 2 to the right. And right there, that's where they're crossing. Down 1 space, 2 to the right. And we've got another line. So what we want to do is we've drawn the 2 lines. Now we want to state what that point of intersection is, and it's 2 spaces to the right, 1 space up. So 2, 1, and that is the solution of that system. Well, let's take a look at another example here, and this one asks us to solve the, well, first of all, we're going to have to graph the equations, the points that they give us, and that's what I've already done for you here. On yours, you're going to end up having a graph. And then notice when I graph, I make sure my intervals are consistent. You can't see the graph paper because it didn't copy, but I went up 2 spaces for each of these points here, and I went by tens. So each space was 5 spaces, or 5 number of bacteria. So the 5 bacteria per space here. And over here I went by 2's, so the number of hours by 2, so there was 1 space in between each of these. And that way I could fit the points on the line. And so it talks about how a chemist is testing the effectiveness of a new bacteria spray. The chemist records the number of bacteria present in the tissue culture after the spray had been used for different periods of time. And so whenever we're dealing with a problem, we always want to figure out what the independent variable and what the dependent variable is. Well, what the bacteria depends on is the amount of time it's been used, or how much time the spray was on there for. So this is our dependent variable. And so if that's dependent, that means that it's on the y-axis. So this is our y value, and the number of hours is independent. So it doesn't, that has no effect. The number of hours has no effect. Well, it has effect on the bacteria, but the bacteria doesn't have an effect on the hours being going by. Hours are just going to continue to go no matter what, whether the bacteria is there or not. So that's considered our independent variable. So we always want to figure out what x and y are and define them. So I've defined them up here. And now we're going to write an equation. So you see how I've got a line. This is called a linear model of an experiment, or sometimes nowadays they call it a line of best fit or a trend line. And so what you're going to want to do is try to get that line between the points. Sometimes you're going to end up getting it right on some points, and I did here. See, that's on the line here, here, and here. And so the idea is to get the line so it represents most of the data. And so what we're going to do is from there, once we've drawn that line, we can take a couple of the points. So I'm going to take this point here, which was 4, 80. And I'm going to take this other point right here, which was 6, 70. And I'm going to find the equation of this line. So I already know x stands for hours, y stands for bacteria. And I'll go ahead and put those into my slope formula. So it's going to be, I'll do 80 minus 70, so those were the y values, over the x values. Since I start with the 80, I got to start with the 4 minus 6. And notice I get 10 over negative 2, which makes negative 5. So that's our slope. Now I want to write the equation, so I'm going to use the point slope formula. Y minus, and then I'll put in the 80, equals that slope times by x minus the x1 value, which I'll use as 4. So I distribute, and I've got y minus 80 equals negative 5x plus 20. Plus 20 because the two negative signs make a positive. So now I've got to do some opposite operations to get that y by itself. So I'm going to add 80 to both sides, and I end up with 100. And so my answer is going to end up being y equals negative 5x plus 100. So remember, y stands for the amount or number of bacteria. X stands for the amount of time. And sometimes it's nice to use the variables, maybe h for x and b for y, if you so choose, to make it a little bit easier to understand. You don't always have to use these variables, but that is the solution, or that is the equation, or the rule. Now it says to predict the amount of bacteria after 18 hours. So I know x is hours, so I'm going to put 18 in place of x. And then it'll give me y, which is the amount of bacteria. So negative 5 times by 18 plus 100. Well, negative 5 times 18 gives me negative 90, and when I add 100 to that, that gives me 10. So 10 bacteria was how many we counted after 18 minutes of the spray being on. After how many hours will, 10 hours, that is, let's see, or 10 bacteria, that's right. So after 18, these were hours in here. And after how many hours will there be no bacteria? Well, no bacteria means that we have a y value of 0. That's where we'd be. This would be 0 bacteria. So in place of y, I'm going to put 0 equals, and then negative 5 times x, because I'm looking for how many hours that's going to be, plus 100. So I've got to do some opposite operations here. I'll subtract 100 from all sides, and do the same thing on this side. And I've got negative 100 equals negative 5x. So when I go ahead and divide by the negative 5, I end up canceling out those negative signs, and that leaves me with 20 equals x. So 20 hours. So there'll be no bacteria after 20 hours is what we're looking for there. So those are the types of questions on tonight's homework. Good luck.